good friend here, Jason. He's going to talk to us about enhancing containerized application with Azure Application Gateway. So thank you, Jason, for joining us. And yeah, stage is yours.
Thanks, Emmett. Thanks for the intro. Hi, audience. Hello there. Jason, greeting from Auckland. So yeah, today I'm going to talk about how to enhance the delivery of containerized applications with a particular Azure service, Azure Application Gateway. So yeah, so I'm sure if you can do like a what do you call thumb up or thumb down, but yeah, but I would hope that like a portion of our audience have some familiarity with Azure Application Gateway service. So yeah, so if you haven't, don't worry. So we'll definitely do a little bit of intro to that service. But this topic is pretty much just revolving around that single Azure service. I think before I jump into the next slide, just a little bit about myself. So Jason, coming from a company called Arinco. So I work with Marcel day in, day out, so in the same team. And coming from initially started as a oh right, probably here. So initially started as a Samuel 2 developer. So probably not a lot of you have heard of this technology, which is a single sign which is a single sign protocol that was quite popular about 10-15 years ago. And yeah, and then slowly get more interested in software delivery and then software defined infrastructure. So I think as the what do you call as a maturity and popularity of cloud native technologies, I think it definitely helped free us developers from waiting for infrastructure. So in that case, we're able to define the infrastructure that is most suitable for our application to be operated on, to be hosted on. And then recently, I think with the wave of AI assisted coding with GitHub Copilot and other AI coding assistant tools, I think it makes us as developers even more productive and creative. So I think the reason that I'm just saying that is just that I don't really think that we should consider ourselves as just a developer who writes code anymore, because we do have all the tools, have all the technologies, so that allow us to not just creating simply programming language, but it also allows us to basically define a lot more stuff that's circling around the application. For example, how the application being delivered and what kind of infrastructure we should run the system, and all the integration points as well with other system or other layers of the system. Right. So yeah, a little bit about our company, Arinco. We are also have the privilege to sponsor the event. We are Microsoft Partner Year 2024 in Australia, and we run our own AI Build Center. Marcel is one of the key member of AI Build Center, and also we provide lots of other services, Azure Copilot, modern workspace, data development. Cool. So right, so that's all about some background, and now let's jump into the actual presentation. So Application Gateway. So for anybody who are not very familiar with Application Gateway, it is essentially a layer 7 reverse proxy. So it is we can treat it as a layer that put in front of your application that understands the layer 7 traffic, which means it understands HTTP traffic. It's able to perform tasks, for example, load balancing, traffic rerouting, and all of these kind of actions for you. So because it has the ability to understand web traffic, it is a lot more powerful than other load balancer. Let's say load balancer operating on layer 4, layer 3. So yeah, it's also support because it's operating on layer 7. It also support SSL and TLS termination. So in that case, instead of handling all the SSL certificates, encryption at your application, you're able to offload that part of task into Application Gateway as well. Yeah, and also it's offering services like auto scaling and zero redundancy, so you don't need to worry about if you suddenly have a spike in traffic. The Application Gateway is able to scale its capability accordingly, and also because it's Azure service, because it supports zero redundancy. So you are able to deploy your Application Gateway instance in multiple redundant zones, so that in that case, any natural disaster happening on one availability center doesn't affect the overall of your Application Gateway service. So again, there are other features that it support because it's on layer 7. You are able to configure session affinity. You are able to perform connection draining, and also you are able to inject something like custom error page. It's just because it's it's pretty much what it does is pretty much terminates a HTTP session and then understands the traffic inside it and able to inject its own cookie as well. And then before the response or request being reached to the destination. So it is acting as a reverse proxy in the middle that help you to improve the experience of your application delivery. So, and again, the standard use case of Application Gateway is that you use it for multi-site hosting. So if you have many different applications that are on different domains, you don't really have to have one application gateway for each of your application, each domain. So you are able to have this what we call multi-site hosting. So you can have a shared centralized application gateway, and then all the traffic, all the web traffic goes into your Azure tenant or Azure landscape will all go through this single application gateway, so that you're able to centralize a lot of kind of operational tasks. For example, logging. You are able to centralize a web application firewall policies as well. So it does give you that benefit. So Application Gateway can definitely be used as a shared service. It's something that if you are following a hub and spoke network topology, this is something I probably want to consider putting in a hub network. Right. Another really, I would call it like a killer feature of Application Gateway is a Web Application Firewall. So it basically comes with a tier of Application Gateway. So what it does is provide centralized protection for your web applications from common threats and vulnerabilities. So this Web Application Firewall comes with the built-in policies that protect you against all the OWASP top 10 vulnerabilities, SQL injection, cross-site scripting, and all the others. And also it supports custom rule sets. If, for example, if you have any specific requirements about if I should be monitoring or blocking any web traffic, you are able to create your own rule set which can detect certain patterns and react accordingly. So yeah, it supports detection and prevention models. So you're able to basically get alerts once a exploit being detected, or you're able to just prevent that traffic from hitting your backend server. Right, and for today's topic, probably the reason why we have today's topic is that Application Gateway also integrates with VNet. So in that case, it can also be integrated into Azure Kubernetes services. So it's able to basically become part of your basically the Kubernetes ecosystem and provide the same level of layer 7 reverse proxying or load balancing and web application firewall features into the application that hosts it in your Kubernetes services. Right. Cool. So yeah, before I jump into what Application Gateway has to offer to Kubernetes services, I just want to lightly touch some basic concept from Kubernetes environment. So yeah, so for any traffic any inbound traffic that goes into the Kubernetes services. Sorry, just about to find the right page. Cool. So yeah, for any traffic that goes inside the inbound traffic goes inside the Kubernetes services, there need to be a what do we call a networking and traffic management component to handle that. So it's able to understand that traffic, need to basically route the traffic to the right backend services, backend pods, and it should be able to perform some basic tasks such as path-based rerouting or load balancing, and also like the HTTP and TCP traffic kind of redirect or differentiation. So all of this can be handled at the moment by two different services in Kubernetes. The first we call it Ingress Controller. So Ingress Controller itself is a layer 7 routing. I think a lot of us have been in the Kubernetes world long enough. Ingress is always something that we configure when we are designing a service in Kubernetes. So yeah, it's a layer 7 routing. There's all sorts of services providing all sorts of load balancing service, URL rewrite, base path rewrite services to the backend workloads. So it is also a centralized way, so you don't really need to have a have a ingress service for each of the to have an ingress controller for each of the services. You can have a shared ingress controller. A lot of us probably have been using Nginx ingress controller or some other ingress controllers. So it is pretty good, very powerful, very easy to plug in, lightweight, but also come with some disadvantages. One of the main issue is that there isn't a very popular standard for ingress controller. Different vendors tend to come up with their own kind of annotation as how I basically consume a service of this ingress controller. So you need to end up to rely a lot on the vendor of this ingress controller, and also need to basically learn a new set of annotation if you are moving from one ingress controller to another. So in that case, to address that problem, Kubernetes Foundation basically released another standard. It's called Gateway API. So Gateway API is basically defining a gateway class and HTTP route. This is just a common set of Kubernetes resource objects, and then the patterns are well defined. So as long as the gateway that is developed compliant to those standards, we are normally treated as a gateway compliant service. And then it also have some more support than Ingress. For example, Ingress doesn't have ability to perform header-based routing. In that case, it doesn't allow you to basically perform, let's say, one good example of using header-based routing is for canary deployment. So you do want to be able to be bounced to a different backend, like a backend deployment. Like for example, if you have a header called canary, want to be bounced into the blue deployment. If you don't have the header canary, want to bounce into green deployment. So that kind of feature is only supported in the new Gateway API implementation. Doesn't exist in Ingress controllers. So so that's pretty much the difference. So you can see that Ingress has been a little bit older standard, but there are probably a lot more results on the internet. But Gateway API, it's been newer, and it's probably going to be the standard for the future as a traffic and networking management tool for Kubernetes services. Right. Okay. So so it goes back to Application Gateway. Application Gateway support both standards. So we have Application Gateway for containers, which is Application Gateway's implementation for Gateway API. So and it's managed by a internal Kubernetes service called ALB controller. So but the web support, because it's a new standard, web support is still in private preview. So if you really need to have Web Application Firewall at the moment, Application Gateway for Container is probably not the right tool for you. So because it doesn't really have the Web Application Firewall support yet. Only if you're happy with the preview feature to be in your production. So so this is a rough architecture. It pretty much like the ALB controller inside your Kubernetes cluster is the one that actually is the one that defines what the Application Gateway container would be like. So you basically have a Azure service that is managed or driven by a component inside your AKS cluster. So and then goes back into the Ingress controller, Application Gateway Ingress controller. So it is a purely what you call a Ingress. It's an Ingress controller that inside your Kubernetes. That Ingress controller is basically managing a full-on Application Gateway instance, and then that is able to translate your custom annotation into a configuration inside the actual Application Gateway instance. So it does also have some really great features. For example, it supports brownfield deployment. So if you have an Application Gateway that is already deployed for other services, for example, for your VM hosted web application, for your Azure web app, so you are able to use the same Application Gateway for your Kubernetes service as well. And so that's what I mean. You can share it with other AKS workloads. And also support Web Application Firewall. You can just use the same Web Application Firewall that are configured on the existing Application Gateway to basically apply the same rule sets onto the traffic into your Kubernetes as well. And also it's slightly cheaper. So because I support multi-site hosting, so in that case, you can use it more of a shared service. So I would consider that slightly cheaper than Application Gateway from containers. So in that case, I'm not going to say there is a clear winner. I'm just probably my current preference is still Application Gateway Ingress Controller because it is mature, has web support. But again, because Kubernetes is pushing this new gateway API standard, so in the long term, Application Gateway for container is something that you definitely want to consider. Right, so there's a little bit of compression. So yeah, cool. So right, and as you can see, Application Gateway for container does offer more kind of more features in terms of the traffic routing and traffic termination. Header-based routing is definitely the one that people would want the most. And it's also query stream matching again. So query stream matching and header-based routing is not supported in Application Gateway Ingress Controller. So this newer standard that definitely have more support onto the more kind of routing or content switching, what you call them, mechanisms. Right. Okay. So yeah, why should we care? I think that's probably a question. Like it's if I'm owner of application, if I'm a owner of platform, why should I care adopting Application Gateway for my workload or adopting Application Gateway for my Kubernetes services? Because I do think there's a reason you should care. Because as the application owner, you are responsible for defining how your application is delivered. So in that case, because you know your application better, you understand your application, understand what kind of traffic routing you want to have, what kind of path-based routing rule that you want to have, and also you probably are more clear about what kind of the volume of traffic that probably gonna hit your application. So in that case, you do want to transfer those knowledge into a tool, for example, Application Gateway. So you are able to, even when you're designing application, treat how the application being delivered to the end user as part of design phase. And then those design requirements, those design specific can be translated into your configuration of Application Gateway. And in that case, you are making sure application behaves the way that you imagine it's going to behave. And also you basically doesn't really have kind of that knowledge gap between how the application being built and how the application being perceived by the audience, by the target audience. And then platform owners should also care about that because as a platform engineer, you want to use your favorite tool to manage the life cycle of application. So with Application Gateway, you are able to perform actions like blue-green deployment and then connection draining. So in that case, you are basically improving the reliability of the application and then increase the uptime of the application. And also you are by using a Azure standard tool, in this case, the Application Gateway, you are able to also standardize and centralize resource monitoring and alerting. That is also a very good benefit because the Application Gateway naturally support integrating into Azure Monitor with all the logging and alerting that you are able to use from the standard Azure Monitor tool set. And as a security engineer, I think you need to care as well because as a security engineer, you want to have a consistent security control across applications. So since Application Gateway has the ability to have a shared web application firewall among different applications, you are able to basically introduce the same sets of same level of web security feature across all your application workloads. And then again, another good thing is you're able to centralize your security monitoring and alerting as well, because again, it's a standard Azure service. It's easily integrated into your monitoring and alerting tools that you configured there as well. So right, I think I've done a lot of talking. So yeah, I will just give you a very quick demo. So hope that works. So right, okay. So cool. So let's jump into my code base. Cool. So yeah, right. So I have already deployed. I probably will. Let me show you what it looks like from a Azure portal perspective. So to start with, so let me open up my portal. Cool. So Right. So yeah. So this is my Azure Kubernetes service, and yeah, and then you can see I got two application gateway. So this application gateway is integrated with Kubernetes via Application Gateway Ingress Controller. So in that case, if we click on the listener, so this listener is created by the ingress controller inside the Kubernetes services. So if I show you very quickly in here, so this is my command line. So if I quickly show you one of the so yeah, cool. So if I show you in here, so show you the ingress. Cool. So you can see this is the ingress that we defined. So you can see this. I think I have a custom annotation just to see that. Okay, so this ingress is basically the spec of this one is the ingress class is Azure Application Gateway Ingress, and then in that case, I'm actually applying the rules. So you see all the rules that we need to apply to the application gateway is part of the custom annotation. So this rule is translated into application gateway configuration, and the change are made from the from the pods to here. So the pods basically have the access to make changes on this application gateway. So if I'm making a changes into the ingress, the change will reflect it as a configuration change in here automatically, because we can see this listener, which is listening on port 80, which is associated to all the rules. So all of this are managed actually not by any person, but it's managed by the ingress by the ingress service inside the AKS. So in that case, so if I visit the public IP, so I think I gave it a domain as well. So if I visit this domain, so this is the domain for the application gateway. If I visit this, and then it will allow me to basically visit. So this is actually an application that I hosted on Kubernetes. So that is working, and yeah, cool. So if I good ports. Cool. So yeah, so I think so that's this one. So it's basically I'm able to hit this port from the application gateway domain via by leveraging the ingress controller. Cool. So that's the ingress controller, and the next I'm gonna show you is the application gateway for containers. So that's a very different service. So in that case, this one here. So this service is the application gateway for containers. So this whole entire service is managed by my gateway deployment in the Kubernetes services. So the front end, you see the front end and associations. So all of this are not managed. So I didn't make any changes. Those are also purely managed by the gateway service inside the Kubernetes. So if I take a look in here, so if I get the gateway service, so I'm just getting the gateway service. You see, this is the gateway service that we defined, and then we're basically saying that okay, so yeah, so we want to use we want to basically use this. So this is the service I showed you, JSON-AE-test application gateway. So that's this one here. So we're basically defining that okay, so this particular service is gonna be the service that we use for this Kubernetes gateway. And then in that case, we also have some custom annotation, and then we basically have all the definition of the gateway as well. And yeah, and then the application gateway for containers will be updated based on the configs that we put in for this gateway, and then this configuration will be translated into the configuration that will be injected into here. Cool. So by creating some front end and by creating associations. So yeah, so cool. So and then I think if you remember in my presentation, I mentioned that one of the advantage of the application what do you call, of the gateway API is that it supports header, what do you call, header based routing. So I'll just basically show you what do I mean by that. So in that case, cool. So I'm gonna be basically to try to reach a endpoint. So this endpoint is the endpoint of the this is the endpoint that hosted on the application gateway for container, which is this one here. So yeah, so I think this one here. Oh no, the second one. Sorry, the second one here. So what I'm gonna do is that if I hit it with a header called canary. So if I'm hitting it with the header slot canary, so and then you can see I'm hitting the blue deployment, and if I'm hitting it without the header canary, I'm gonna be reaching to the green deployment. So this feature is only available in the gateway API implementation, because Ingress Controller doesn't support this. So yeah, so this is the so this is what the what these two options are, and how you basically implement those two options with the support of the application gateway. Obviously, you are able to implement a similar thing using internal services. For example, you can use AGIC Ingress Controller. And you are able to implement your own kind of your own implementation of the gateway API. But however, by leveraging a Azure service, for example, an application gateway, you're not just achieving all this nice routing, nice traffic balancing, but also you are able to leverage a lot of very feature from application gateway as a service. For example, Web Application Firewall, logging, monitoring, all of that going to be naturally become part of the what do you call, the system that you have. So just before I wrap up, I just quickly, I think as you can probably see, so we don't have HTTPS. So we don't have HTTPS. It's everything HTTP, which is bad. So in that case, I'll just show you how easy to make it from HTTP to HTTPS. So this is a little bit of the this is a little what do you call? This is some Kubernetes manifest that I put together. So just if we run it, yep, cool. All right, and now if we run it again, excuse me, put it into S, and then unfortunately I need to do a K. Yeah, so we got HTTPS. So just how easy it is to achieve that. And remember, so all these kind of settings, like those are just standard Kubernetes settings. So we're not really introducing any complexity by introducing application gateway. So all the same way that you're able to deal with your Kubernetes workload, it's the same, but because application gateway supports the Ingress Controller standard, support Gate API standard, you can integrate it natively into your Kubernetes services while enjoying all the goodies from the wider Azure ecosystem. So that's the end of my presentation. Any questions?
Yeah, so good. Thank you so much, mate. So I'm getting an echo.
Cool.
Yeah. Can you hear me?
Yes, I can.
Yeah. Thank you so much. Yeah. So I know that with every new technology, people a lot of the time has got some misunderstanding or confusion. What do you see people confused with the Azure Application Gateway? What is the most thing that people immediately get confused by?
Yep. Ooh. Oh, sorry. I just had a glitch. I think some of my slides got crashed. Sorry, can you repeat your question? Sorry, Matt.
Oh no, it's all good. It's all good. Yeah, it's all good. What I was saying is that so first of all, thank you. That was really good, amazing session. Appreciate your time. My question is, do you normally when you talk about Azure Application Gateway, see people get confused by a specific topic or something that is really difficult for people to understand, or they get confused immediately with something else, some other service?
That's a really good question. Yes, I think it is I think it's the confusion mainly coming from on which layer Application Gateway operates on. So I think a lot of people say we get the standard load balancer, which is already does a really good job on doing load balancing or sometimes doing the source netting. But why we want to have a application gateway? So I think you definitely have that same people asking the same question as well. So for me, I always try to explain to that, like if you're using if you're a load balancer doesn't understand the traffic. It doesn't understand if it's HTTP traffic, HTTPS traffic. It doesn't understand it doesn't have the concept of session as well. It's not able to basically to inject like a custom cookie because it's operating on that level. But we'll move up to layer 7. You have a lot more control on the traffic. You are able to know you have the visibility of the headers, the path, the query string. So all of that can be used to make a more kind of granular traffic management. So I think that's one thing that I think a lot of people get confused, and it's just different layers, different layers.
Yeah, Matt, makes sense. Thank you, Jason. Really appreciate your time, and thank you for sharing your expertise.
Thanks, Matt. Same to you. Yeah.